Okay, it's May 31st, 2012, and Bran and I are tinkering with OpenROV, as we often do. So what we've got set up here is something that's pretty cool. Right now we're using a Beaglebone to control an Atmega328, which is running the Arduino software. Basically what we're trying to do is control a servo, which will ultimately be the motor controllers for the ROV, without actually needing the full Arduino. Eventually we're hoping to make a cape that will go on top of this and have all this junk. So we were having a problem. It seemed like the servo was kind of glitching out, and we weren't sure if the serial data we were sending to the microcontroller was incorrect or what the problem was. So we hooked up one of these Saleae logic analyzers, and they're pretty cool. We just plugged that into the serial output from the GPIO on the Beaglebone, and we plugged that in here. Now we're running their software, and it shows the commands that we're sending. So this is looking at the serial data, and you can see G, what is that brand, 0?
O.
G-O. Oh, right, go. And then the values, 128, 128, and 128 for the three respective motors. And it looks like the serial data coming out of the Beaglebone is correct.
Before we actually knew how to set it up, we had to try and figure out what the bit encoding was. And you know, neither of us are very experienced with UART serial, so we just started, you know, poking at it and trying to figure out if we could figure out which were ones and which were zeros. And decided, hey, actually this looks like a different Manchester encoding. So we started looking that up, and then Eric found the correct encoding on here, and then it showed us, boom.
Yeah, it turned out it wasn't Manchester. We were completely wrong. That's not the first time by any means. It turns out that obviously now we realize this should be asynchronous serial. So we went down here, async serial, let's see, channel 0, and so then it shows that. So now it's showing the G character, the O character, and the values for the servos. So, what was the problem? We kind of thought about it for a second, and then we realized this is a hardware issue. That's my problem, isn't it? Okay.
A little bit.
So Brand pointed this out. We're using a crystal to make the chip work correctly. It has this little 16 megahertz crystal, and the plans called for 2 capacitors that are 22 picofarad, and these said 22 on them. That's not actually 22 picofarad. That's, what is it, 200 picofarad or something?
Yeah, yeah.
At any rate, the capacitor values were wrong, and we're like, it'll probably be fine. But now we're realizing the problem might be because we're not receiving serial at the right rate because the oscillator is not tuned perfectly. So we feel like this is a fairly low-level problem. I mean, we're getting into the actual components and how that's working with the computer system and figuring out problems because of this cool technology. So,
one of the first steps too, you'll probably notice this LED here and be wondering why that's there. That was just to make sure that we were actually receiving a signal first before we started doing the logic analyzer.
Yeah, we're just looking for that to blink and see if that makes a difference. So, pretty cool, right?